Let us now warmly welcome Architect Nirodha Gunadasa, the Vice President of CTBUH Sri Lanka, to the stage. His opening remarks promise to provide us with valuable insights and perspective that will guide us on this intellectual journey.
So what are the revolutions you have heard of? Most probably you will say industrial revolution. So if industrial revolution is a revolution, AI revolution is not going to be a revolution. If industrial revolution is a revolution, AI revolution is an explosion. Because technology has always been developing, not fast, but exponentially. The problem is our human mind is we are not geared to understand exponential growth. What we can do is we can think only linear growth. To illustrate that, I'll show you an example. This is 0.1 millimeter thick paper. If I take this and fold it once, the thickness of this paper will be 0.2 millimeters. If I fold it once again, the thickness will be 0.4 millimeters. The question is, if I fold this 42 times, what will be the thickness of this paper? Just 42 times if I fold this. Do you believe that it will be taller than me? I think no one will believe. But if I tell you, if I fold this 42 times and put it here, it will hit the moon. Will you believe it? So your engineers just do the calculation. I think on your phone you can do it's 0.1 millimeter into 2 to the power 42. The answer is 450,000 kilometers. It is more than the distance from Earth to Moon. We can't imagine it because our minds are not geared to think what is exponential growth is. The thing is, technology has always been developing exponentially. And it is Ray Kurzweil who is first noticed this, and this is his graph. So he noticed how technology was developing gradually, and in year 2000 around, he said, right now, an average computer's processing power is equal to one insect's brain. It's like the brain of a cockroach. He said, but in 10 years' time, it will be equal to a mouse brain. And in another 20 years, it is going to be equal to a human brain. To explain this, this is a better graph. So the blue line shows the human intelligence. The important thing is it is also growing. The red line shows the exponential growth of AI. And by year 2030, something important is going to happen. The processing power of an average computer is going to be equal to a human brain. So that is called artificial general intelligence, AGI. And by 2045, an average computer's processing power will be more than all human brains in the world together. So that is called artificial superintelligence. So between this period, something important will happen. Now, as human beings, we have created a machine that is smarter than us. Can this machine create another machine that is smarter than us? If it cannot, how can it be smarter than us in the first place? So definitely these machines will create machines that are smarter than them, and those machines will do the same, and there will be a huge development of intelligence, and there is going to be an intelligence explosion. This explosion will continue rapidly, and according to the model, by 2100, it will consume all the matter and energy in the universe, and the universe will become one giant thinking machine. I don't believe it is true. Nobody believes, but for last 30 years, data shows each day, each year, it is marching on this particular curve he has predicted. So it is the only viable model we have right now to explain how AI is going to develop. So I don't know whether it is true or not, but one fact is clear enough that today we are at the verge of artificial general intelligence. So that is a fact. And even though most of us even don't know what artificial intelligence is. So that's why we have this forum. So when I show people a graphic like this and say, this is a building I have designed, some people, even professionals say, you have AI generated this. So when I say this is not AI generated, this is a computer generated image. They say computer generated, that means AI generated. So for them, AI is just another fashionable word to say computer generation. What is artificial intelligence? Do you have an understanding? This is Gary Kasparov in 1997. So when we were school children, I noticed this event. So IBM Deep Blue computer defeated the world champion and became the world chess champion. Does this has anything to do with AI? Is this AI? No, it is not. Deep Blue is not an AI computer, and this is a machine defeating intelligence. There's nothing to do with AI here. So what is artificial intelligence? A simple explanation is artificial intelligence is brains living inside large computers. They are digital brains living inside large computers. When I say large computers, not just little bit bigger laptops, large computers are things like this. They compile several warehouses and massive number of GPU units, and it consumes power of sometimes more than one entire power station, and it generates a lot of heat. So that kind of a thing is a large computer. So AI is all about digital brains living inside large computers. So seat of intelligence for animals has always been their biological brain. So that is seat of intelligence of animals, and therefore the seat of intelligence of artificial intelligence has to be an artificial brain. Whether it is natural brains or artificial brains, the brains has a simple building block. That building block is a neuron. So if you understand what a neuron is, you understand basically what artificial intelligence is. I know it's foolish thing to try to explain what a neuron to this kind of an audience, but I'm going to do that foolish thing. Okay, I'm trying to explain what a neuron is. This is a father. His height is X. This is mother, her height is Y. So we are going to create a neuron to identify the height of their son. So this is how we are going to do that. We are going to multiply X by W1, Y by W2. W1 and W2 are just two numbers. We multiply them and then we put it through an equation. Let's say for simplicity X plus Y. And we get an answer. And that is the height of their son. So let's say the height of the father is 1 meter. Not so tall, isn't it? And the mother is 1 meter. So W1 and W2, I don't know what these numbers are. I will just assume they are 1 and 1. So we get an answer of 2. And this is, let me see. So this is their son. And we know his height is not 2, his height is 1. So there's an error of 2. This setup is called a neuron. And the important part is when we know what is the error is, we can send this error back through the equation and calculate what is W1 and W2. So that is called back propagation, and that is also called training and also learning. So that is how a neuron works. So in actual cases, what is at the center is not a single neuron, but a network of neurons. So this is a neural network. And there are a lot of W's, and if you consider a large-scale language model like ChatGPT, we are talking about these layers about hundreds, and these W's we are talking about millions, and interconnections of neurons we are talking about quinzillion numbers. So it's a massive one, and I'll represent this in my talk, xn is all the number of parameters that we enter. This triangle kind of a thing is the neural network, and the outcome is z. So I'll use this to represent a neural network in my talk. So neural networks are very important today because they can learn any language. For instance, the people have tried recording the noise made by whales and then put it in neural networks, and now they understand how these whales talk to each other. They have recorded the sound of bats in caves, so thousands of bats are shouting. They have recorded it, and now they understand what these bats are talking. And at least we know each bat has a name like Hiromal and Gayan and so forth. So they also have individual names. So we know because of these neural networks. And this is human genome. We have everything recorded, but there is no one on earth to look at this and say, this is how this DNA sequence is converted to my eyeballs, my eyebrows, my hands, and how these protein structures are made out of this. And that is what Google AlphaFold kind of things are doing. So they can manipulate how these proteins are folding, and then from DNA to protein conversion. So it is now in progress. So it's happening fast. And then the computer vision. The computers can see nowadays. So this is 15 years ago, people said there's nothing like human vision. Computers will never be able to see things like humans because this dog, and we train a typical computer to identify dogs, and we put this image and say this is a dog, and then if you show this to a typical computer, how can it recognize this is a dog? Because everything is different. Each pixel is different. So even if we train it, how can this be a dog? And then for the worst case, how can this not be a dog? A typical pixel-based computer can't do it. But we can do it because we have a concept of dog developed in our brains. And it seems these neural networks can do it even better than us. So how to do it? The way I said, we put several examples of dogs, a data set, put it into a neural network, and the neural networks have to say, yes, it is a dog, no, it is not a dog. When it makes mistakes, we back-propagate and let the system learn what a dog is. So when you do that, what happens is, inside this neural network, it develops a lower dimensional representation of dog. In our terms, it's a concept of a dog. So because now computers can see things, now these autonomous cars are getting popular. These cars can see people and identify people, see signal lights and recognize signal lights, see rocks and recognize these are rocks. And most importantly, they can see dogs and recognize these are dogs. So they are getting popular now. In many cities, we see autonomous vehicles are coming, and they are going to come to Sri Lanka also very soon and revolutionize the way we transport. This is a Google robot, Tesla robot. And because now these robots can think like we think and see like we also see, they can hear like we hear, and also we can train with neural networks for them to move like we all move. So Tesla says 10% of their warehouse workers will be replaced with these humanoid robots by 2025. And after that, it will be commercially available, and they are planning to manufacture at least billion of them, and each person will get one. The estimated construction cost of one robot is less than $10,000. So this is what vision has done, and there's more. So this is human retina. So looking at this retina, an AI system can detect the exact diabetic level you have, your blood pressure, your kidney disease, the liver disease, gallbladder disease, Alzheimer's disease, and hyperlipidemia. So all that AI system can detect looking at your retina, which not a single human expert can do. So those are some of the examples of neural networks, and can we do this? Can we run this neural network backwards? It's not for training, but we'll enter the height of this son and we have to come up with the height of mother and father. It's sort of possible. One would be a solution, but height of father 0 and height of mother 2 will also work. But those are not probable things. So we can train this neural network with a little bit adjustment. So we can run it backwards and then come up with the most probable answer for the height of father and the mother. It's possible to do. So that is what this generative AI does. So we insert dogs this side and we generate the concept of a dog outside. What will happen if we run this backwards? We will add the same thing backwards and run. There comes a dog from the other side. That dog is totally different to all the dogs we have used for training it. We can do things, they are doing things better than that with dogs, because to create the concept of dog, I need not to put pictures. I can create a concept of dog with poetry of dogs. And we connect encoder poetry, the decoder paintings. With poetry, we can create a painting of a dog. So this is called, this arrangement is called transformers, and this is what generative AI does. So this Indian lady doesn't exist. It's an imagination of this AI system. This beautiful dress she's wearing, no one has designed such a dress. It's imagination of an AI system. By the way, can you recognize anything wrong with this graphic? It's almost like a photograph, but anything correct. So if you look at the hands of this lady, you can see the fingers. It is the AI system has made a complete mess out of it. So I particularly selected that, then it's a proof that it's not a photograph. Okay, good. Right. So generative AI and transformers can do many things. It can transform poetry to paintings, text to image, text to video, and most importantly, we can now transform text to 3D models. So when we are working with 3D imagery, 3D modeling, and so forth, especially architects, you need to find models right now, go search in the internet, buy them, just give a prompt, it generates the 3D model you want. And sketch to BIM is not available now, but I think it will come very fast. So when we do a sketch of a building, we put it into the transformer, it will generate the building information model. It will come very soon. Text to DNA is there, and text to protein is there. So that is what generative AI is doing these days. And the final word, the simulations. So this is a fluid flow. I think most of the engineers work with them. Can we use a neural network to detect what is happening in this fluid flow at the next moment? It's possible. We put it into a neural network and it will generate an output. This is the fluid flow the next moment. We can do it, but to do it accurately, we might need a huge data set, as you learned, to generate it. But nowadays, engineers has found there's a better way of doing it. We can do it without that. And that is called PINs, the physics-informed neural networks. They are getting much popular these days. So what we do is, this is the fluid flow we insert. It generates the output. So it says this is the output. This output has to be physically accurate. For instance, the mass there has to be the same. So mass has to be conserved. The momentum has to be conserved. So if it is a incompressible fluid, the divergence has to be 0 and it should satisfy the Navier-Stokes equations. So we need not to have that massive data set to train it. With this, we can recognize whether this output is correct or not. We'll ask the neural network to train by itself. Do a test, train by itself, and then learn to come up with the right output. So pins are going to be popular and they are going to devastate our field of engineering and architecture soon. So fluid mechanics, heat flow, smoke flow inside buildings, the people flow inside buildings, the seismic things, all those things will be easy to simulate. So the simulations you are doing right now with maybe 1 day long, maybe 1 week long, can be done almost real time with pins. Okay, so that is what AI is doing these days. And today, the artificial intelligence systems are far less intelligent than us. There are a lot of things they cannot do, and there are a lot of strange gaps. If you try to work with them, you will notice. And to be honest, I am not using it for any kind of serious design work actually. But I must say this situation is quite temporary. With the rate of progress we notice, sooner these digital brains inside computers will be as smart as us, or maybe smarter than us very soon. And we call that kind of AI, AGI, artificial general intelligence. Such an AGI will have a dramatic impact over every area of human life, every activity of human life and our society. When it happens, the impact of such artificial intelligence will be extremely vast. That will overturn how we live, how we get things done, how we behave, and also what we are itself. How these deteriorating limbs will be replaced with the new materially generated limbs and then organs, and our brains will be connected to a cloud, and we will have better memory and better thinking capacities, and human beings might become immortal as well. So what is to be a human will also be changed. And as CTBUH, this is the important thing, that will overturn the urban habitat. Because our cities are what we are and how we move around, what we do, our economy. So when all those things change, our entire urban habitat will be overturned. So the last thing is when it is going to happen. So according to Elon Musk, he says 2026 AGI will come. The Ray Kurzweil model says 2029. I don't know. But it is obvious that we will see AGI coming within this decade. So it's most probable. So this is the conclusion. We are at an inflection point of human history, and you'd better be alarmed. So that is an oversimplified. Actually, I did many oversimplified things and an extremely brief introduction to the AI revolution. That's it. Thank you.